about comparing and rounding whole numbers. Please take notes through the video as you need to. Pause it, rewind it, whatever you need to do so that you understand these concepts. The first thing we're going to talk about is comparing numbers. Now, there's a couple steps when we are comparing whole numbers. Remember, whole numbers are the numbers in front of a decimal. First step, count how many digits are in the number. So let's do that to begin with. This has 1 digit, 2 digits, 3 digits, 4 digits. This has 1 digit, 2 digit, 3 digit, 4 digit. If one of these had more, then you already have your answer. The one that has more would be the one that is bigger. If you have the same amount like we do in this example, then you need to go to step 2. Step 2 says you're going to start on the very left side of the number. Right here, the very first one is a 5, and over on the other side, the very first number is a 5. So we're going to cross those both out because they are the same. Our very next number is a 4 and a 7. Those are different, so we are going to circle them. It does not matter any of the numbers after. Right here, 7 is bigger than 4. So, as I like to say, Pac-Man likes to eat the bigger number. So 5,498 is less than 5,702. Let's try some more. Again, first step, count how many digits. 1, 2, 3, 4. This one has 4. 1, 2, 3, 4. This one has 4. So because they have the same, we are going to cross out starting at the very biggest number. 3,000, 3,000. 400, 400. 6 tens, 5 tens. 6 tens is bigger than the 5 tens, so Pac-Man eats that bigger number. Again, it's important to show your proof. Your proof is circling where they are different, or your proof would be in if they had a different amount of digits. Let's try the next one. First, we're going to count digits. 1, 2, 3, 4, 5, 6, 7. This side has 7. 1, 2, 3, 4, 5, 6. This side has 6. We do not need to do any more comparing because 7 is already different than 6. So Pac-Man will eat our bigger number. Let's look at the next example. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Because they have the same amount of digits, then we compare them. 2 10,000s, 3,000 versus 9,000. 9,000 is bigger. 3 digits, 3 digits, so we compare. We have a 4 to start. We have a 3 to start. They are different. 4 is bigger than 3. Please make sure when you show work that you show where the answers are different or where the digits were different. By circling that kind of proof, you will guarantee to get a right answer. Sometimes you might have these in word problems. The lake location of Tom's TVs earned $196,561 last year. The store's ranch location earned $122,180. The location with the greater earnings gets an award. Complete the explanation to find which location gets the award. Well, because we're trying to figure out which one is greater, because we're using a word like greater, we can make our own Pac-Man bubble. And we can write our two locations down. So now we just created a comparison problem. 6 digits, 6 digits. So I have to compare. They both start with a 1, so I'm going to cross it out. Next, I have a 9 and then a 2. They are different, so I'm going to circle them because they are different. 9 is bigger than 2, so my Pac-Man is going to eat the bigger side. This one right here was our lake location. This one right here was our ranch location. So now we can answer the actual question. Since the lake location earned more or less than the ranch, well, the lake location, Pac-Man is eating it, so it is the bigger number. It has more than the ranch location. The blank lake or ranch location gets the award. Well, again, if we look back up here, it says the location with the greater earnings gets an award. So the one that had more is the lake location. So the lake location is our winner of the award. We're going to move on to our next topic. Our next topic is rounding. Here's a good little poster that maybe can help you with your rounding rules. Rounding rules. Find the number, look right next door. 5 or more, raise the score. 4 or less, let it rest. Hopefully we can let our digits rise or rest. So it's really important to remember these right here. 5 or more next door. It is going to go up. 4 or less, we're letting it rest. It's going to stay. So here's some rounding rules. Feel free to pause the video and take some notes. You're going to first underline the rounding digit. Then you're going to look at the digit behind and draw an arrow to the underline. That number tells you what to do. So first we're going to round to the nearest 10. 1, 10. So we're underlining the digit that we're rounding to. The number behind it tells it what to do. The 9 isn't saying anything. It's the 2 that's telling us what to do. 2, according to our rounding rules, 2 stays the same. So we're going to stay the same with that one. So the 9 stays a 9. Everything in front of it stays the same. Everything behind it becomes a 0. So my answer for rounded to the nearest 10 is 5,390. Now we're going to do the same procedures with our next problem here. Sometimes the best thing to do is to rewrite your number because it really is a separate problem, even though it's using the same information. So now we're going to round to the 100. Ones, tens, Hundreds. The 3 is in my hundreds place value. The number behind it tells it what to do. The 9 is telling the 3. 9 tells the 3 to go up. So the 3 is going to go up to a 4. Everything in front of it stays the same. Everything behind it turns to a 0. So my answer rounded to the nearest hundred is 5,400. Let's try a few more examples. This problem is actually one problem, two problems, three problems, four problems, five problems. Because this is actually 5 different problems, you're going to want to show work for all 5 of them. So the very first thing you would do is rewrite your number that you are starting with. Now we're going to round the number to the nearest 10. Ones, 10. The number behind it tells it what to do. Remember, 4 says stay. So the 1 is going to stay. Everything in front of it stays. Everything behind it becomes a 0. So my answer that I would type into the box or put into this box is 680,910. Making sure that I don't have any digits after where it wanted me to round to. So for our next one, we have to start by rewriting our problem from the start again. We always want to go back to the start. Now we're rounding to the nearest hundred. The 1 tells the 9 what to do. The 1 says to stay. So the 9's going to stay. Everything in front of it stays. Everything behind it becomes a 0. So my answer is 680,900. Notice when we rounded to the nearest hundred, our answer actually got smaller than when we were rounding it to the nearest 10. That's going to happen at times. Just making sure you show your proof, you will come up with the right answer. Pause the video now and try the next ones on your own. Resume when you're ready. Okay, welcome back. Hopefully you came up with these right answers. Check your work. We're rounding this one to the nearest 1,000. Because there was a 9 in the hundreds, it told the 0 to go up. So this one is 681,000. Our next one, we're rounding to the nearest 10,000. So the 0 told the 8 to stay. So we get 680,000. And the last one here is the 100,000. The 8 told the 6 to go up. So we get 700,000. You might get problems that look more like this. Select yes or no to each number to tell if the number shown below is rounded to the nearest 1,000. Pay attention to what words are in the direction. Nearest 1,000. Now, the setup of these problems look kind of goofy, but they're really easier than you think. The top number is your starting number. The bottom number is your rounded answer. So if we put down our starting number, which is the top one, and we round it to the nearest 1,000, ones, tens, hundreds, 1,000. The number behind it tells it what to do. 5 says go up. So this 5 is going to go up to a 6. Everything in front stays the same. Everything behind turns to zeros. So now we look at our second number. Is that the answer we got? Yes, it is. So we would mark yes on this question. Again, the very first one is your starting amount. In all these problems, we're rounding to the nearest thousand. The 7 is in my thousand. The 8 tells it to go up. So the 7 becomes an 8, and everything behind it becomes a 0. My rounded amount is 8,000. If we look over here, this does not say 8,000. It's not even rounded to the nearest thousand, because if it was, there would be no digits in the hundreds or the tens. So this one is a no. Let's take a look at this next one. 64, 388, rounded to the nearest thousand, ones, tens, hundreds, thousand. The 3 tells it to stay. So the 4 is going to stay, the 6 stays, and everything behind turns to zeros. Again, notice right here in our rounded answer, we have digits behind the thousands place, and you cannot do that. That does not turn out to the answer that we proved. Let's take a look at these next couple. We start with 958,085. Well, glancing at our answer, we have all zeros after the thousand, so it's looking promising, but let's prove it to make sure. The 8 is in the thousands. The 0 tells it to stay. So everything in front stays. Everything behind turns to zeros. And we have a match. Yes, it works. Let's look at the last example on this page. We write our starting number down. We underline our thousands place value. And the 8 tells it what to do. 8 says go up. Now here's where it's a little bit tricky. The 9 is going up to 10. What that really means is the 0 goes in the place value, the 1 goes into the 1 next door. So really, this answer becomes 50,000, which is this answer. Sorry, I almost marked the wrong one there. It's also good to go, is 49,826 closer to 49,000 or 50,000? And sometimes using that strategy can also help guarantee that your answers look good. That is it for our lessons. Please make sure you do some practice of comparing and rounding of whole numbers. iExcel is a great choice. Worksheets, get some good practice in so you're ready for that unit test.